Hello everyone, so in this video we are going to discuss regarding ternary solid solution, but before that I'll discuss 2 points of ternary peritectic. I left that while teaching you ternary peritectic. Okay, so you have already seen this diagram, right? So, as what is the example in ternary peritectic? In binary peritectic, example is here. Let's say leucite and quartz. In between, we are getting orthoclase, right? So, the binary peritectic example is like this. Similarly, if we take here leucite, quartz and let's say anorthite, okay. So what will happen here? So I have taken already, yes, there is one more line here. This is your anorthite and orthoclase line, right? This is your orthoclase. This is similar to this I have told you in ternary peritectic. Okay, if you cannot remember, you can see first that video, then you can come to this. So ternary peritectic, in ternary peritectic I have described all these diagram. I have taken so many points, like I have taken points here, 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 so I have described all these points. What are the crystallization behavior for these points? Well, I left 2 of the points. Like, let me say this is one point which is on this line, okay, anorthite and orthoclase line. So this is one point, anorthite, which is present on the line connecting orthoclase and anorthite. Then what will happen? What is the end point here? Similar to binary peritectic also. So we have discussed regarding this point, we have discussed regarding this point, this point, this point, right? So let's consider a point here. What will be the final composition if I will take a composition on this orthoclase line, or here in ternary orthoclase and anorthite line, right? So in case of binary, what will happen? Similar process. When it will touch here, when it will touch here in this point, then you are finding leucite plus liquid. There will be formation of leucite. Then this is the peritectic point. It will move towards peritectic. When it reaches the peritectic point, then you are getting, let's say this is 1. At one point you are getting leucite plus liquid. So phase is 2. Here it is binary we are talking about. So P plus F will be equal to C plus 1. So C is equal to 2. That means 2 plus 1, that is equal to 3. So degree of freedom is equal to 3 minus P. Degree of freedom is equal to 3 minus P. So here number of phases are 2. So degree of freedom becomes 1. At point 1, degree of freedom becomes 1. So it will follow the curve, move towards P point. At P point, what will happen? At P point you are getting leucite plus orthoclase plus liquid. This orthoclase, as I have told, it can be formed in 2 ways, directly from magma or from leucite and SiO2 from this liquid, okay, that can form orthoclase. So here phase becomes 3 degree of freedom becomes 0, right? That is 3 minus p, so degree of freedom becomes 0 here at peritectic point. Okay, so now the case is at peritectic point what will happen? Either leucite will be finished or this liquid will be finished, right? There are two cases. I have told you, if we are taking any composition before this line, if we are taking any composition in this zone before this line, what will happen? Liquid will be finished and end point you are getting leucite plus orthoclase. If you are taking any point beyond this line, after this line, then what will happen? Leucite will be finished and you are getting what? Orthoclase plus liquid. Then you move to eutectic and then quartz will crystallize, you will find orthoclase plus quartz as end point, right? These are the two cases. If we are taking any composition before this line, the end point will be leucite plus orthoclase, because at peritectic point P, all the liquid will be finished and there will be remaining leucite and orthoclase. If you are taking any composition here beyond this line, you are finding orthoclase plus liquid, because all the leucite will be finished there, you will get orthoclase plus liquid, then there will be two phase, then that will move to eutectic and crystallization of quartz happens, then at the end point you are getting orthoclase plus quartz. Okay, but now thing is, if I will take any composition here on this line, so what happens at point P? At point P, what happens? Both liquid and leucite will be finished at a time, right? If you are taking any equation on this line, you are going to find only orthoclase as end member, only orthoclase as end member of crystallization. Okay, if we are taking any initial composition on this line, that is orthoclase line, we will get only orthoclase at the end point. Okay, this is the case of binary peritectic. Similar to this, in ternary peritectic, what will happen? If we are taking any point here on the line orthoclase and anorthite, what will happen? Again, this is the field of, this total is the field of leucite plus liquid. This is the field of leucite plus liquid. Then what will happen? The first mineral to crystallize is, let's say this is X. So at X you will find leucite plus liquid, right? So phase is equal to 2, and as you can see, this is P plus F is equal to C plus 1. Here C is 3, because we are talking about ternary system, so that is 3 component. So F will be equal to 4 minus P. 4 minus 2 will be equal to 2, that is your degree of freedom. Degree of freedom becomes 2. When degree of freedom becomes 2, what to do? You have to connect with the vertices or vertex, right? This is leucite, so you have to connect this leucite to this point, then it will move like this. Okay, this is your peritectic or reaction point, this is your cotectic, ternary eutectic or cotectic. So let me erase this line so that you can understand. Okay, so from X to let's say 1, what will happen? Leucite plus liquid. From X to 1 you are getting leucite plus liquid. At point 1 what will happen? You are getting leucite plus orthoclase plus liquid, because this is the reaction curve. This is the reaction curve, right? On the reaction curve you are getting orthoclase due to what? Leucite plus liquid, and another method is directly from the liquid or magma, right? So there are two means of formation of orthoclase on the reaction curve. Okay, because this is the common boundary of orthoclase and leucite. This is the common boundary of orthoclase and liquid, as well as this is the reaction curve. As it is reaction curve, leucite is getting converted to orthoclase. As it is common boundary, you are also finding orthoclase from the magma, crystallizing from the magma, right? Then from 1 to P it will move, 1 to R. At R, what happens? As I have told you, here now degree of freedom, number of phases is 3. If number of phases will be 3, degree of freedom becomes 1. Okay, then degree of freedom 1 means it will follow the curve and it will move to R. At R what happens? You will get lucite plus orthocase. R means here, right? Here this is the common point between lucite field, orthoclase field and anorthite field. So you will get lucite plus orthoclase plus anorthite plus liquid. Okay, so number of phase becomes 4, degree of freedom becomes 0. Number of phase becomes 4 and degree of freedom becomes 0. Now the magma will move from R to further, that means towards C if lucite will be finished. If lucite will be finished. If lucite will be finished, then only one of the 4 phases must be finished, must be ended, so that it can move forward. Unless it will be invariant. If phase will be 4, it will be invariant. So here either lucite will be finished or liquid will be finished. If lucite will be finished, then you are moving towards C. If liquid will be finished, then you are finding lucite plus orthoclase plus anorthite as end member. Okay, but I have taken the initial composition on orthoclase and anorthite line. I have taken this composition on this line itself. So what happens here, both lucite and liquid will be finished at a time. Okay, both lucite and liquid will be finished at a time, and the end member you are getting orthoclase plus anorthite, because initial composition you have taken on orthoclase anorthite line. In final composition also you are getting orthoclase plus anorthite. But this is an incongruent system. This is an incongruent system. Why? Because if you are not, this line is represented in a dotted line. This line is represented in a dotted line. Why? Because we have taken this composition on this field of, this is not the field of orthoclase, right? Orthoclase field is here. We have taken this composition in the field of what? Lucite, in the field of lucite. But in final composition you are getting orthoclase plus anorthite. You are not getting lucite. You have taken initial composition in the lucite field, but you are getting orthoclase as the final product. So that's why it is incongruent. Okay. So as I have told, if it is on this line, orthoclase and anorthite line, you are getting orthoclase and anorthite as final end product, and lucite and liquid, they will be finished all together. Okay. Then I will tell another point here. Another point here. Let's say, let me erase that. Let's say I am taking any point here. This is a field of orthoclase plus liquid. Okay, let's say Y. That is the point Y. So what is the first mineral to crystallize? This is the field of orthoclase plus liquid. So you are getting orthoclase plus liquid. So number of phase becomes 2. Number of phase becomes 2. When number of phase becomes 2, degree of freedom becomes 2. In case of ternary, that is 4 minus P, because component is 3. 3 plus 1 equal to 4 minus P. So the degree of freedom becomes 2. When degree of freedom becomes 2, what to do? You have to join the vertex. As this is in the field of orthoclase, as this point I have taken in the field of orthoclase, what to do? Not with lucite, you have to connect Y with orthoclase. You have to connect Y with orthoclase, not Y with lucite, because you have taken it in the field of orthoclase itself. So you have to connect orthoclase and Y, it will move like this. Okay, you have to connect orthoclase plus Y, so it will move towards this curve. That means this is the eutectic curve between what? Orthoclase and quartz. It is the eutectic curve between, or common boundary between, orthoclase plus quartz. Let's say this is 2. So at 2 point, what will be the resulting minerals? Orthoclase plus quartz plus liquid. Phase becomes 3. Degree of freedom becomes 1. So it will move towards C. At C, what you will get? At C, you are getting orthoclase plus quartz plus anorthite plus liquid. Okay, then liquid will be finished. You are getting this as final product. Okay, phase will be equal to 4, degree of freedom becomes 0. Okay, then liquid will be finished. Then final point you are getting orthoclase plus quartz plus anorthite. If you have taken any point here, initial composition here, you are getting what? At point C, the final composition will be orthoclase plus quartz plus anorthite. Right. So these are 2 points, this point on this orthoclase anorthite line and this point on this field of orthoclase. I have missed these 2 points in case of peritectic, so that's why I repeated it here. Once again, if I'll take any point here, it is same case. First mineral will be your orthoclase, then you have to connect with this. It will move to this curve. Then you are finding, or here you will get orthoclase. Let me clear this. So if we will take any point here, the first, let's say this is Z. Okay, at Z, you will get orthoclase plus liquid. Then it will move towards 3 point. At 3 point, this is phase equal to 2, so degree of freedom becomes 2. So you have to connect with the end point. This is Z, right? This is Z point. So you have to connect with orthoclase. It will touch the curve. This is the curve between what? Orthoclase plus anorthite. This is the curve which is boundary between orthoclase field and anorthite field. So at 3, you will get orthoclase plus anorthite plus liquid. Phase will be 3, degree of freedom becomes 1. So it will follow the curve, it will move towards C. At C, what will happen? What will you get? You will get orthoclase plus anorthite plus quartz plus liquid. Phase becomes 4, degree of freedom becomes 0. This is invariant. Now liquid will be finished. At the end member, you are getting orthoclase plus anorthite plus quartz at C. Okay. So these are few points what I have missed. I hope all of you got this. First you can see the ternary peritectic video, then you can come to this video, right? So that you can understand. So now let's start ternary solid solution. That is simpler than this ternary peritectic. So we have already studied binary solid solution. So in binary solid solution, what are the example? Like phosphorite and phyllite from olivine group, then diopside and albite and anorthite from plagioclase group, right? Like that we have studied so many examples. In case of binary solid solution, what is the diagram? Let's say this is albite, this is anorthite. As I have told you, albite means this is sodium oxide plus silicate, right? This is NaAlSi3O8, right? This is the composition. So sodium, aluminium silicate. So let's consider this part only, because rest part will be common to anorthite. This is CaO calcium oxide plus aluminum silicate, right? So anorthite is having higher temperature, albite is having lower temperature than anorthite. So the graph is like this, right? Anorthite is having higher temperature, albite is having lower temperature. When you will take any composition here, what will happen? It will move downward. It is your liquidus, this is your liquidus, this is your solidus. Now this is solid plus liquid, right? When this composition, this is the initial composition, now you are decreasing the temperature. This is the temperature axis, right? So we are decreasing only the temperature, not changing the composition. When it will touch the liquidus, what will happen? You have to plot a tie line. You have to plot a tie line to know what is the fast mineral to crystallize. To know what is the fast mineral to crystallize, you have to plot a tie line. What is the meaning of tie line? Tie line means it is representing what? The solid. It is representing the solid which will be formed due to this composition of liquid at constant temperature. You can see this is the line, means it is the line of constant temperature. Here if I made a line like this, y will be constant. In xy coordinate system, y will be constant. That means temperature is constant. At this constant temperature, this composition of liquid will produce a crystal of this composition, which is rich in calcium, Whatever you take initial composition, the final, the fast composition is, the fast mineral to crystallize is your calcium rich or anorthite rich. As it is removing calcium from the liquid, as the solid is formed from the liquid and it is taking out the calcium, the liquid will be rich in sodium. The liquid will be rich in sodium. This crystal, what it will do? It will intake sodium into it, and it will move towards albite rich composition. It will move towards this side, albite side, right? The fast mineral will be formed somewhat here. Let's say bitonite. Okay, this is anorthite, then the series is albite, oligoclase, andesine, labradorite, bitonite and anorthite. Let's say the fast mineral is bitonite. Okay, anorthite rich I have told, anorthite rich. Okay, that means calcium rich. Okay, so that is the bitonite, let's say. So if the fast mineral is formed is bitonite, then what will happen? It will add some sodium and it will move towards, what? Next composition, labradorite, like that. Okay, so solid will move in this way, liquid will move in this way. Liquid is giving calcium, that's why it is become sodium rich. The solid is removing some, taking some sodium from the liquid and adding it with, taking the sodium, it will become sodium rich, or it will become albitic in composition. Okay, more albitic in composition. So solid will also move towards albite, liquid also move towards albite. I have already taught you this in binary solid solution. So you can check that, then you can come here. So I am just remembering these things, reminding these things so that you will get it. So till what it will move? The solid will move till this composition, right? Like this, these are the tie lines. It will move till this composition because it is the initial composition. When the solid composition reaches, solid will move like this, na? It is moving like this, When it will reach at this point, that means the solid composition is, the present solid composition is the initial composition of the liquid that we have taken. Okay, the present solid composition is, this is the present solid composition what we have taken, the initial liquid composition. So at this point, what will happen? Here all the liquid will be finished. At this point. liquid will be at this composition, liquid's composition is this composition, solid's composition is this composition. At this point liquid will be finished and you will get entire composition of this crystal, and I have already told this is in case of ideal condition. If there will be some temperature change, you are going to find zoning or whatever phenomenon. Okay, so this is the scenario in binary solid solution. Then let's move to ternary solid solution. Same thing will happen. Okay, albite anorthite will take in one end and the other end we are taking something else, some other mineral. Let's say here I will take dioxide. So it is dioxide. Here I am taking albite and anorthite. Here I am taking albite and anorthite. So as I have told, only one line of the triangle, only one side of the triangle is showing the solid solution. That means if I plot it like this, here it is the solid solution like this. Right, anorthite is having higher temperature, albite is having lower temperature. So here I am getting what? The solid solution. And between dioxide and anorthite, you are getting eutectic. You are getting eutectic. Between dioxide and albite, you are also getting eutectic. Right? So let's say let's project this eutectic here, this eutectic here, and this is the solid solution. This is the solid solution. You are not finding any common point here or like eutectic point here. So you are going to join this like this. Okay? This point is representing what? Eutectic point between dioxide and anorthite. This point is representing eutectic point between dioxide and albite. Okay, between albite and anorthite, you are not getting any eutectic point or common point of crystallization because it is showing what? This is the solid solution. This is the solid solution. Okay, now let's start analyzing the crystallization behavior. Let me erase this one. So if you are taking any composition here, as I have told, this is your dioxide plus liquid field. This field is dioxide plus liquid. If we will take any composition here, let's say X, so first mineral to form is dioxide plus liquid. First mineral is dioxide. So phase becomes 2, degree of freedom becomes 2. When degree of freedom becomes 2, what will happen? What you have to do? You have to connect with the vertex. So it is moving in this direction. Okay, let's say x2, this is y. So at y, what will happen? It is same like I am taking any composition here. In binary, forget about dioxide. In ternary, I am including dioxide. In binary, let's say this is the initial composition, this is y. So I have taken a composition here, right? If the temperature will fall, it will touch a point here. Then what we have to do in this case? If this is the liquid, this is the liquidus, this is the solidus, right? If it will touch here, then we have to make a tie line like this, right? That means this composition of liquid is producing the composition of solid, or this composition of solid means calcium rich solid. This is calcium, this is sodium. So wherever I will take composition, if here or if here, then I have to connect it with this, then it will touch here, then if it will touch here, initial composition is here, then the solid will be at this composition. The solid will be this composition. This is for, let's say, Z. Okay.